All right, thanks everybody for coming to the pre-Thanksgiving week office hours. First off, let's see, I think this is the first office hours we've had, I guess it's second since the VOLTTRON 7 release candidate with Python 3 support. We've had that out for a bit, and hoping people can give it a try. Craig, did you want to talk about some updates in that arena? You there, Craig?
Yeah, so we've been hard at work making sure that all of our tests are passing locally and working to get those passing up on our continuous integration side on Travis. We've also started pushing stuff to a code quality check engine that's open source, and we'll talk about that later. In addition, the web refactor that I'm working on is got lots of test cases going on, and we have decided that instead of having all the web components automatically be installed, we separated it such that we have a streamlined base install, and then you can add just like with RabbitMQ, you add that on top of the base with the bootstrap --web. So that's one modification that is in the process of becoming part of the core. We pushed that change to master, so that right now one of the issues on Raspberry Pis is that the CFFI framework is not as easily installed. There isn't a wheel already made, so you have to have extra components on it in order for it to play nicely with VOLTTRON and some of the secure token authentication stuff that we're doing. But it's not required in the base platform that is using just plain 0MQ. It would be required for the web authentication stuff. So that's where we're at. Hopefully on Monday we'll release the second candidate, and then going forward at that point we'll probably not add much other than hopefully some deployment stuff, but and then we'll make the final release beginning of January for 7.9. So that's all I got.
All right, thanks. Yeah, and if anybody is interested in trying out the Python 3 version or has tried it out and has comments, let us know.
Oh, and next Friday it will probably be merged into develop. So any polls from that will be Python 3. We'll probably send a note out to the list maybe Monday, Tuesday of that fact, so that nobody is caught unaware when they pull and can't run their stuff anymore. Because it is definitely a backward compatibility change.
Yes. Yeah. All right. All right. We're going to have James run through a tutorial about creating your own drivers. Before we launch into that, I just wanted to make sure, just open the floor. Are there any questions or topics that people wanted to bring up, or is everybody good with launching into the drivers? Ian, Dan, is there anything that you wanted to cover in specific?
No.
All right. All right. Well, with that, then, James, you want to go ahead and take over?
Sure. Can everyone hear me all right?
Yep, sounds good.
Okay. Let me know maybe when you see what I've got here.
Yep, it's showing.
Okay, cool. So this tutorial is somewhat basic for potentially users that have, a lot of experience with device communication, especially through VOLTTRON. But it's intended to be a walkthrough of exactly what would need to be done to create a new VOLTTRON driver. So I'm going to kind of explain it from the most basic components, and then I will talk about an example that we are going to have in the examples directory, which can be used as a sort of guide. So in essence, VOLTTRON driver is a type of almost like a sub-agent running under the master driver process, which is responsible for being the communication interface from the VOLTTRON platform to the device. So the way that communication typically happens is that you have a master driver installed, which is configured for some device, and that master driver will scrape the device on an interval. Alternatively, you can send requests to the driver to get a device, and you can interface with the actuator agent to set points on the device. So the master driver does this through the device's interfaces. So when you have a device you want to set up, the master driver will require that you've created an interface class that it will call certain methods of for this communication, and the interface class itself will require a set of register classes. So as you can see here, and I will show my directory structure as well, an interface class is expected to be under the master driver agent directory interfaces subdirectory. The reason that this is that the master driver looks in that directory for a Python file with the same name of the driver. So I have a configuration for this driver here. You'll see that this name of the driver type and the name of the CSV file match exactly. So that will have to be the case in order for your driver to be used by the master driver. So when you've created that file, you'll want to create an interface class skeleton, which will consist of, at the most basic level, methods for configuration, getting and setting points, and then another method which will get all of the points with one call. So that will provide the most basic functionality. It is the case that you may require additional functionality. The BACnet BACnet interface rather is one example of an interface that will have additional functionality beyond these, but this is sufficient for very basic devices. And in the case of the example device, these are the methods that I will have implemented. So the configuration given by the device configuration will be used here. So the interface class uses one or more register classes underneath it, which are used to describe specific points on the device. So that's a one-to-one relationship. If you have a device with 10 points, you will have 10 instances of a register class.
Hold on just a second, James.
Sure.
Scroll up just a little bit.
Sure.
And I asked this question in chat too, but is it required that this be named interface?
The class be named interface?
Yes.
Yes.
Okay. I just wanted to make that clear because
yes.
that is actually what is being called to instantiate this object.
Right, and it's expected that you'll implement the base interface interface, or rather extend the base interface. And the reason that that is that that has some of the basic configuration built in and some of the basic functionality behind some of these, behind some of the features that the master driver expects you to have built into it. And if you want to take a look at that, that's found here. No, sorry. Yeah, here. So you can scroll through this guy and see all of the things it expects. For example, there's a register map, which contains maps to readable and writable bit and byte registers, and things like things of this nature, functions for getting the register you're looking for and then creating new registers and all of that. I need to be able to see chat here. There we go. What's the second question? The scraping interval is in seconds. Yes. So is that pretty clear, do you think? Craig?
Yeah, I think that's
Okay.
I think that's good. The main point is, number one, that while you can name your file whatever you need to, it has to be referenced in the config file, and it has to have a class named interfaces or interface that inherits from at least base interface.
Right. Right. Go ahead.
I was gonna say, and I believe you can do fractions of a second if you need that. We tested that a while ago.
Oh yeah, you can certainly do fractions of a second, but a lot of devices don't allow you to do that, or you won't.
You can pull it that often, but your answer is not going to change more often than just at a second interval.
Right, and it's just it's a float value, so it's 0.5 works just fine. So.
Okay, and the things that Craig and I are discussing are all documented in this walkthrough, and to some degree also in this driver development page and read the docs. The link is here if that's something you'd like to take a look at. There is a little bit of overlap, but again, this documentation here is meant to be more of an actual walkthrough of creating an example. So we have the interface class. The interface class is going to use one or more register classes. These should, much like the interface class, be using using the features of the base register class. Again, that's in the init method here, or the init file. So let's see. Yeah, right here, right. So it'll has functions for getting some metadata about the register, and then some default included values and that sort of thing. So this class is at the most basic level used to sort of specify the sort of attributes needed to look up the register. So
yeah, so his machine froze because that's good timing. So I think what we'll do is he can record it offline and then we'll post it. I don't think it's worth trying to recover from that and getting back into it. So sorry about that, everybody.
So, Ines, we could take a look where this is right now, or not. I mean, I suppose that's up to training, but we could look at the pull request that's out there. If you wanted to look at that, we could at least share and show.
Yeah. Okay.
This is out in a pull request, and basically basically viewing the file that James was looking at. And as we're going through here, this literally is supposed to be a walkthrough on how to create a CSV device driver. So basically what this is, it's going to be one of the most bare bones interfaces that you can have. It's going to be pulling a CSV file for changing for values over and over again, and you're able to set a point on it and get the point and scrape. And that's basically what we're going for with this example class.
Yeah, and the point of that is to show, there's all different devices, each with different ways of interacting with them, and this points out where exactly you need to put in the code to talk to something new, implement it for a new protocol or something like that, so that you can start working with it. And there's examples of more complex ones with the BACnet and the Modbus drivers and that sort of thing. But this is a really clear minimum. Here's what you would need. Because we'd want to, as these communication methods get added, we want to, prefer them to be in the format of the driver, so they're standard. Sometimes people create separate agents to do the communication, and there could be cases where that makes sense, but generally it'd be best if they were in the driver format. So yeah, if you want to go take a look at that, it's in a pull request now, but soon will be merged in with the rest of the documentation. And I apologize for the technical difficulties. We'll get a recording of it offline and posted so that people can follow along.
Just for some context of why we're actually doing this, here at PNNL, we've got some new devices that we have, and we want to have other people develop the devices. We have a group of interns that are here for us. So this document is meant to be part of a training class that we're going to give with them, and hopefully that will go well and smooth. And then having it out there to everyone certainly makes
sense where you can. Oh, great! Can you guys hear me?
Yeah, it's suddenly better.
Suddenly better. Okay. Well, that means that my Bluetooth headset is not doing its job very well. Because that's what just happened. My power came off. Huh. Anyways, so now we.
So hopefully we'll have a larger device population. The VOLTTRON can rule the world.
There you go. Yeah, and that's something that we'll probably present in a future office hours too, is there's a IoT cybersecurity lab being stood up at PNNL that we're going to, separate from VOLTTRON, but including VOLTTRON, we'll be putting devices through their paces to see what their different cybersecurity postures are and that sort of thing. And as Craig said, we have some interns who are going to be writing drivers to talk to those devices. So, all right. Yeah, and Craig's, your audio went back to regular.
Back
but
to regular.
Anyway, again, I apologize for the technical difficulties. Fun with computers.
Anybody have any questions?
Yeah, we'll open it. Are there any questions or any topics that people would like covered in a future office hours? We want to make this as useful for you as possible. So if there's another walkthrough or a specific component you'd like covered, just let us know. And if you want to think about it and reply to email, just send it to volttron@pnnl.gov, and we're always looking for topic suggestions.
And if you guys are not on the Slack channel, just go ahead and post your email. And I jumped underwater again. I love that. Post your email and we'll add you to the Slack channel or send it to voltron@pnnl.gov.
All right. Well, I think there's no questions, and we'll call it here. And everybody have a good Thanksgiving next week. And we will see you in December. Yep. Thank you, Ian. Talk to you later.